Hello and welcome. I'm Bill Wake. We're here working on a program to assess tune similarity. We generate Parsons code reports, which are kind of a graph of the melody's direction up or down. And we are parsing it from a file notation, a music notation called ABC, which is a commonly used file format for music typesetting programs and stuff. Even if they don't use it, they can almost always generate it. All right, let's see where we are. Oh, something's weird. Hope. Hope the rest of it looks okay. All right. We left off with some failing tests. Let's take a look at these. And we should be able to diff this. Okay, so what happened is we used to put the title and the Parsons code, which is these letters, centered on the first line of the graph. We're going to a form where we're going to put the title and the Parsons code, a blank line, and then the graph. We just have not done that yet. So I edited the answers to be right, but we haven't done the code to really do it. All right, let's go ahead and kick that off just to let that get warmed up. And let's find Parsons code report. Well, that's a file. Okay, good. Parsons code report, I think, is the one doing that. Okay, yeah, so here we see the current one. It creates the code grid and a title grid, and then puts the code grid on the left and the title grid on the right. So it adds horizontally. We'd like to add vertically and put the title grid first. Okay, so I can at least do that. Okay, and then, well, I'd really like to say something like title, I want to say something like this. Let result equals title grid dot plus vertical, I guess, lines one blank line, and code grid. Okay, but the problem with that theory is there is no plus vertical. We got a plus horizontal, but we never had the need for a vertical before. So let's go ahead and develop that separately. So I'm going to kind of ignore those failed tests and work on some grid tests. Okay, so do we have grid tests? Yes. Grid is still sitting out there. I don't know. It's kind of a generic. It's a very generic class in a way because it's got no knowledge of the reports themselves or anything like that. It's just got blocks of characters. And maybe, well, someone suggested I do more kind of a actual graphics graph instead of a character-based graph. It's like, okay, that might be worth doing, but not today. Okay, so what we're going to do is check this plus vertical thing. Okay. So this function plus vertical puts first then second. With blank lines. Okay. All right. So we have grid and grid.put. I think we'll just do some of the same stuff. I'm not trying to prove like the grid already. Well, the two things about it, it's got the notion of an axis, the 0 line, and it's got the notion of if you put something outside the current range, it will expand the range to accommodate it. But I don't really need to test that stuff. I'm just gonna test these grid things, and let's go look at put. You know, this is probably one of these times I'm gonna refactor first. Okay, I know I'm refactoring on red, but I think it's so easy to get confused on these, especially if you get rows and columns and X's and Y's, and notice that X is actually the column and not the row. So I messed that up in my life a number of times. All right, so if I build, everybody who uses this should complain slightly. All right, where's my build? No. This should really be complaining about X, and this should be X, Y. So weird. Okay, pose it. X, Y. Let's build again. Okay, now we'll run tests and the tests will build. Okay, and we do that all over the place there. X. I would say in general, Swift, probably Swift best style is more named parameters than I tend to use. I don't know. I did a tiny bit of Smalltalk back in the day, and I've done some Ruby, and there's other languages with name parameters, but most of my programming has been without them, I guess. Okay, and you'll see why. You know, I may be hurting myself by trying to do this refactoring while I'm doing this. Okay, so my choice is either back out, check in red, or comment out those tests and check in anyway. And I think I'll do the latter. Now IntelliJ would just do this for me, or app code would probably just do that whole refactoring for me, no problem. And it also puts the, in IntelliJ IDEA anyway, it puts these in kind of in a light gray text anyway, you know, even in Java where you don't have them. So yeah. And notice it's mostly tests. That's probably a good sign on the production side. There's not a lot of places that have that knowledge. Okay, a couple more. Okay, alrighty, so now let's comment out this one, comment out this one. Oh, check reports. Okay, I'm going to take that out for a second. Okay, we'll check this in. Add X and Y to grid.put. And maybe I'll leave this check reports for the moment. Okay, let's put this back in. This test should fail. Should build, but fail. Actually, 0, 0 on this one. I don't know, Y2. That's okay. I want to check the assert. Okay, let result equal grid 1 dot plus vertical lines 2 and grid 2. And then I want to assert the result should be all right. So the first one puts A, B, C, E, F, G. Let's make this one a 1. X is 1, Y is 2. 1 blank line, 2 blank lines. This goes at Y2 offset by 1 column. And then I don't really know if it, I think it's going to put the 2 blank lines as well. Let's make this 3. Okay, so here's grid 1, here's our 3 blank lines, and I think this is what grid 2 will look like. Let's see if we can find another example. Yeah, I don't think I really have one, do I? Text. I don't know why I'm bothering with this dot stuff. Okay. Well, that's my claim. I may be wrong on this, on what happens when I claim there's a y-axis 2. Do I really create rows for 0 and 1? I think I do. All right. Now let's go to grid. All right, there is no plus vertical, so we got to add one. Vertical lines of int and other of grid yields a grid. Okay, and result equals grid of self, so we'll make a copy. We don't have to conform heights. Yeah, we don't have to worry about heights. I don't even think we really have to worry about horizontals either. Let's go back up to representation. Okay, so we have the width is maintained by this. The height is the line count. Positive rows is the axis location. Okay, where's the contents? There's body. Okay, so I think what I can do, well, what I want to do, we'll return result. This will give us a wrong answer. Oh, it compiles. Okay. We got A, B, C, D, E, F, G. Okay. Let's see. So we got the original grid. We know we need to put some blank lines in. Okay. Let's do 0 dot dot less than lines. For each. Okay. And we're going to do body dot append. Well, I think it's an empty array. Is that right? Okay, so we've appended our blank lines. Let's run and see if that piece looks like it's coming along. Okay, whoops. Where did that output go? In here? A, B, C, D, E, F, G is not equal to that. Looks like it's trimming those off then. Oh, but we haven't really done it. Um, hmm. Let's see. I guess we'll need to add. We'll need to add empty row, or yeah, empty row to the body. Okay. But now the height, oh, that's body.count. That should be fine. Where did they go? I would still think that should be an empty line. Okay, let's see. We appended these. The width should be unchanged. The axis can be unchanged. The height is body.count. Positive rows. Well, we've added negative rows, so that should be untouched as well. Okay. I'm a little puzzled. Oops, I saw another brackety thing. There's that one and that one. Okay. All right. So, well, and let's how about other dot body dot for each, and this is row in. Let's do sorry, this should be result dot body dot body dot append row. Okay, and that may be right. Now that I'm putting it on result dot body, I probably should have realized that sooner. Yes. Okay. So what we're saying is the axis of the final thing is the axis of the first one, and we're just going to append in the blank lines and the body rows, and everything else will be maintained because we're not changing the axis or the positive rows. We're not changing the width. Well, let's see what the width is, how the width is managed. Oops. Now we do mess with that. Okay, let's see if we have an adjustment. Conform horizontal. Okay, I think we can move forward with this. Run everything just to make sure. I'm not quite sure that width is maintained properly, but we'll see. Let's see. So we add plus vertical to grid. Okay, and then Parsons code report tests. Let's uncomment this again. Go back to this. Okay. And let's go to our reports. And kind of the line I commented out. This one now should go away. Let's see how that does. Okay. Oh, one of them worked and one of them didn't. Probably easier to read over here. Song with one graph. R's, just see R's graph is not equal to one, just see R's graph. Why is that dot, dot, dot? Take this one first. One just C, bunch of R's. Oh, it's got a new line. That's on me, I think. Right, there should not be a new line there. Now, I wanted 2 lines. How do I want this between them? Well, I want a line in the middle between them, that's for sure. I don't know. I'm doing something wrong on the this. I would like to have 2 lines between. Okay, I guess I do. Okay. Run them all. And we'll check that in. Let's see. Make report, put title, then graph vertically. All right, let's pull no scaling and run this thing. Okay, so I'm going to put that there. Generate report. Now the downside of these reports, they do get big. Okay, there's a relatively normal length one. Good. That's looking pretty good. I am sure Fiona will be very happy with this. It does admittedly get a little weird as we grow. I don't know why we have some that are just huge. But you can see, like, this tune kind of hangs around, da 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 da. This one hangs around and then breaks out into that. And this one looks like it's just going, whoa. This one's mostly up. This one's almost all down, right? Those are probably not the same songs. Now, those two look very similar. Almost, dare I say, identical? Pretty darn close. Okay. There's one that's mostly down, one that's mostly across, you know. An extremely long one. Not the longest. Oh, there's that long one. Yeah. La-di-da-di-da-da-da. Okay, so I'm very happy. Let's see. So that does that. I guess I'm still hung up on this width thing. I guess I'm not as concerned if there aren't enough spaces. I believe it puts them in. Let's see. There's a put. Okay. If it's greater than or equal to width is +1. We append spaces to get there. Okay, so I think that implies, and I don't know, we need to find a way to bring this out better maybe. The width, the grid is always maintained with the width that it says. Is that true? Yeah. And if we go appending, like we don't know, the width of the new one might be wider than the old one, and that's not going to be good. Okay. So just like there's a conform height, I think maybe there's got to be a conform width. And I think that's kind of implicit here. This is the kind of thing that's conform width. We're taking the current width, adding a space to each row, and yeah, so I don't know. That's the kind of thing we're going to need to do. All right, let's figure out. Let's write a test. Okay. And it's going to be something like this because we just want to demonstrate that. Okay, plus vertical conforms all or both grids to same width. Okay, so how can we spot an error? Well, let's make this one shorter. And this one is let's make it A, B, C, D, E, F. Okay. And where can we see this? What would make something go wrong? I guess if we did a grid horizontal, right? That would show it. Let's put this back to 0. Let's put this back to 0. And let's make a grid 3. Is grid 3 dot put. Let's put x0 and y0. 1, 2, 3, and then in x0, y -1, let's put 4, 5, 6. Okay, and let's make grid 1 plus vertical. Oops. Plus vertical plus horizontal space is 0 grid 3. Okay, and so what we expect to see is grid 1 is ABC, and it's got the lower. Okay, so here's grid 1. Now grid 2 is ABCDEF, and we're putting it vertically. Let's put 0 lines, and then that ABCDEF. Okay. We put those two vertically. Now we're appending horizontal grid 1, 2, 3, 4, 5, 6. Well, it should start. That should really be bum, bum, bum. 1, 2, 3, 4, 5, 6. I guess if I added one space in there, that would probably make it a little cleaner. Okay. That's what that should be. My prediction is 1, 2, 3. It's ABC space 1, 2, 3. The two lines are totally different lengths. Okay. Build field. Grid 3. Put. Okay. ABC space 1, 2, 3. ABC's multiple spaces. Okay, so I'm guessing right. All right. So what I'm saying then is the result of this thing should conform them. All right. And what do we have? We have conform height to. I think we need to conform width to. Yeah. So let's say conform width to. Where's conform height to? Okay. To, and then I think we can get the count. Well, actually, I think if we just say the width we want, right? Desired width of int, and that should modify this grid. Okay, and the way you conform is kind of like this. Well, it's kind of like this. I'm going to borrow this for a moment. Okay. Desired width. Maybe this is minimum width. No, I think it's desired width. So I don't know what this X is. We don't need that, I don't think. So what we're doing, we're basically going to go through each line, right? This part's kind of right. Go through each line and then replace that line with the result of appending this. And the count is probably desired width. How many spaces do you need? Minus what's there. Well, this is not even body.enumerated. We don't have to do that, I don't think. I think we have to go 0 dot dot less body dot, well, height, yeah, body dot count. Okay, so if we go through each index, for each index in there, really wish it wouldn't do that. Okay. I don't know what this is. We don't need it. Okay. So we're saying run through the height for each row in this thing, append enough spaces to make up for the row it's not there. So let's say we need 3 spaces. We want a width of 3. The current count is 0. Then we're going to take 3 minus 0 and put 3 spaces in. Okay. If the count is already 3, we'll put 0 spaces in. Okay. I think that looks right. Now I got to say at the end here, I'm going to make a result conform. Result.conform height to, and then it's got to be the max of self dot height, no, width. Let's conform with the maximum of our own width and the other width. Okay, so whichever one's the biggest, conform it to that. All right. And I think that should do it. All right. Make when adding vertically, conform new grid width to larger of original grids. Okay. And I want to refactor, like conform grid width, this thing. If x is greater than or equal to width, x is greater than or equal to width. Okay, so yeah, if we need to, well, one thing I can see is we're not using string in this, right? So let's ignore that. Let's see if that still works. I'm going to try and change this thing piecemeal, I guess. Okay. So this is width is x plus 1. That looks to me like conform width to x plus 1. Okay. If x is greater than or equal to width, conform to x plus 1, and then we can write target x. Okay. Man. Okay, if desired width is already right. Okay. I guess if it's equal, it's 0. Where's my mouse? My mouse just died. Okay, what's your problem here? Body subindex.count. This is really not equal. It's actually really greater than, right? All right, run that again. Well, where is it failing? Fewer positive or negative rows on the left generates them. Okay, my thing went wrong, so let's just undo. Well, does this seem right? If the desired width is equal to body.count, we don't want to do it because this is count of 0. That's apparently that's not legal. I would have liked it to be, but it's not. Okay. If desired width is less than body index.count, that means the body index is already wider than we're saying it's got to be. I guess we don't want to do anything in that case. But this, let's put this back. Make sure this works. Okay, so why is this not conform with 2? Okay, width is x plus 1, so we append enough for x plus 1. Okay, well, the next thing I can do is 0 dot dot less than height. Height. We don't need it enumerated. Oh, well, we can leave it enumerated. Index that. Okay, let's make sure that's okay. All right, now we don't need it enumerated if we take out the unused variable here. All right, so what's the difference here? 0 less than height. So for each row, we're going to take that row and append a bunch of spaces to it. If the width, okay. Now, down here, 0 less than height for each index in body index dot append. Why is that not the same? Width x plus 1. I'm going to copy this code up there. Zero less than height for each. Let's make desired width. Okay. Body subindex dot append contents of array repeating spaces count desired width minus body subindex dot count. With this caveat, and I'm saying desired width is greater than what we have there. Is that quite right? If desired width is equal to the body index.count, we don't want to do it. Okay, but if desired width is greater than, then we have to add spaces. I don't know. The different... Okay, I've done something off. Wait a minute. What did I just do? I'll put this back. Okay. Copy this. 1, 2. How about that? Okay, we're still in the x greater than or equal to width. Maybe I'm off by 1. No, if I want to write in x and I want to write in 0, I need my width to be x plus 1, so x plus 1. If x equals width, then we got to write 1 more. Okay. So I don't see why this should be any different. And yet it is. Zero is not equal to 4. Or maybe that's an O. But regardless, what the heck? Oh. Oh. Okay, I guess it's quoting my width is 0. Oh, width does have to be reset. Yes. We need this line because width is the variable we're tracking. Okay. Yeah, let's try now. Okay. So now I think maybe conform width to is the one that ought to be doing the reassignment of the width. Okay, conform width to. After you've done all this, width equals desired width. Okay, and so now I'm saying conform width to x plus 1. Let's take this out. Make sure that's the right one. Yes. Okay. I believe this should work. Yes. Okay. I believe I should select the stuff I really want to delete. Okay. That's looking better. This can move down. Okay. Conform width to. Conform width to. There's a way to filter this. Cannot convert nothing to bool. Oh, I need $0 in there somewhere. Filter those. Let's take this out, since we already know that's true. Okay. Let's see what we've done. We've make put use conform with to. Good progress. All right, now. Okay, so we've set the width, we get the result. Alrighty. Let's see our to-dos. Change report to show reference and title on the first line. This part we haven't done yet. To split Parsons code every 32 characters. It's somewhat arbitrary, but a lot of music comes in 32 note chunks, so I don't think it's totally arbitrary. We have done this though. Let's see. So this is 22-18. Okay, and I guess in there we make grid able to do plus vertical. Okay, so I think I'd like to do this next. And that's whoever's writing that Parsons code needs to just break it into chunks. All right. Okay, so I think rather than start that right away, let's take a quick break, 3-minute break, then we'll come back and make this every 32 character thing start working and go from there. All right, see you in about 3 minutes. Hey, welcome back. All right, let's see, I pulled up a couple pages, sequence and string. Let's see if there's anything in either of those that just kind of does the job of splitting stuff up. Contains. Well, there is prefix. Yeah, that would be possible. And we could take the prefix by X characters and do something there. Formatted. Split. Oh, this is promising. Returns the longest subsequence in order that don't contain elements satisfying the predicate. Not really what I want. Omitting empty sequences where separator returns a slice. The longest subsequences that don't contain elements satisfy the predicate. Max splits. Well, I don't want that. So far, prefix suffix looks like the easiest thing to do. Just kind of run through and pull those. All right, let's see what strings got. Lots of ways to create strings. Remove. Filter. Subscripts, prefix, int. Yeah. And let's go check what prefix gives us. Infrequent. Okay, maybe this is infrequent. Nope. Prefix int returns a subsequence. Okay, and we can convert it back in if we need to. All right. All right. So let's give report. Well, I almost want to parameterize report. Let's see. I don't think we'll affect grid. Parsons code, no. Report. So I kind of want to say, the tune with maximum width of Parsons code being, something. Okay. Splitting, I don't know what we'd say. Tune and code. The titles, there's the code. Okay. All right. Report takes a bunch of tunes. Okay. Well, I mean, we can start max code width of int equals 32. All right. I don't think anybody's going to blow up from that. Seeing as nobody references it, right? Okay. And then report for one tune can take a max code width of int equals 32. Again, nobody's referencing it, so nobody should blow up. Okay. And let's pass that into the title grid too. The details, okay. Max code width of int. Okay, now we may get some complaints. Certainly we can pass it here. All right, let's see if anybody calls details. One test. Okay. I don't think he really. I don't think it's really critical that he tests through that entry point, but that's okay. All right. So I think we've added a little bit of stuff to make that possible. Let's put in a test that takes advantage of it. Report, how about Parsons code respects max code width? Okay. And details, we're just passing in the max code, so that's just fine. Okay, I don't care about the tune without title, reference 1. Let's call this tune. And title is title. Okay, but this, I'm going to say 5. 1, 2, 3, 4, 5. 1. Oh, it's 1, 2, 3, 4, 5, up. 2, 3, 4, 5, down 2, 3, 4, 5. Okay, so this should be star. Oh, what is that? Yeah, it should be the broken up. 1, 2, 3, 4. You. All right, done. Okay. And this is going to fail. Because it puts it all in one line. All right, and the result, expected result looks like what I want. Okay, so let's make detail. Basically, this is going to have to loop. Okay, so let's see, var. Okay, I guess we'll start with remaining code dot code, and then while remaining code dot count greater than 0, we're going to do something, and I guess we're going to say int lines equals 0. Okay, so how many lines have we written out? Okay, how about var lines equals 0? Okay, so I've got remaining code and I've got the lines. Let's make this -1 minus lines. All right, and we're going to put remaining code dot prefix of max code width. Okay, so we write out the front of it, and then we assign the rest. Remaining code dot equals remaining code dot suffix from max code width. Oh, am I in the wrong type? Okay, this we can make. Should be able to just make a string out of this, and a string out of this. All right, and then we need to add to index. Is there another suffix? From takes an index. Ugh. Strings are just such a pain to work with. Okay, let's find suffix. Suffix from index. And let's go find self.index. Well, that's not really. Okay. How do I get something that gives me the index? Oops. Prefix while. Oh, up to, but not including the specified position. That's promising. Index of self.element. Oh, where's start index? Yeah, string index. Okay, first character. All right, let's work with index then. Okay. Let index equals 0. No, it equals remaining code dot start index. Okay. So this let me do this. Lines. Okay, we're going to add a line. The line we're working on is the next line. Okay. We'll take the remaining code's prefix for the width, and then maybe it's prefix. Max length up to. How about up to? I'm thinking too hard here. Okay. You'd think there'd be something that just splits a line. Okay. Um, let's just check. I think I looked for something like that before earlier in my life. Swift split string every n characters. Yeah, separator. Yeah, I mean that's doable. Yikes. Every stride equals if stride. No, that's probably not ideal. I don't think it has to be that hard. I think stride was his function, right? Maybe not. Let's try Swift stride. Ooh. Returns a sequence from a starting value to, but not including an end value, stepping by the specified amount. And that's on sequence. Well, that's kind of promising. Stride. Okay, let's try that. Stride from through from to by. Okay. Stride from let's start at remaining code dot start index to remaining code by dot end index past the end. Okay, I think that's okay here. Whoops. By max code width. Okay, and then in here, what do we get? Degrees equal interradians. Create a sequence I don't know if I have to do a for. It seems like it should just produce a value. Okay. Okay, I think I want to do this part. Okay, and then string. Well, let's see what we get here first. I want to do remaining code sub. Next. Next. Next was max code width. Does that look okay? No. Cannot be applied to operands of type underscore and int. Cannot convert substring. Well, let's fix that one first. All right, there must be a substring that. Right, dot dot listen. Okay, that's kind of what I was trying to do. Okay, subscript range string.index. Well, I can use prefix, I guess. I don't know why I'm being so stupid on this. You would think there'd be a simple substring, though. Everybody likes having their indexes. Where was that first one? Back up here. Search and create a substring from prefix. Next plus code width. What's the type of next? Error type. Okay, that's. Let's do this. For index in stride this, do. Sorry, for next. Oh, is that a bad word to use? that. Okay, now what are you? Good old error type. String.index is not stridable. Okay. Okay. Well, I like the prefix suffix thing if I can make it work. All right. Let's try that again. Okay. While remaining code.count is not 0. Okay. We're going to print a string. Let next piece is the string with remaining code dot prefix of max code width. Okay. We'll put that in the result. X0, Y -1 minus lines. And next piece. Okay. And then lines is 1 greater. Next line. All right. Now, the trick is I want the rest of the string. Remaining code is remaining code dot suffix from index. There's got to be another one that can we do this? Max code. Max code with that. Member subscript. Remaining code. Oh. Remaining code sub that. Subscript is unavailable. Cannot subscript with an integer range. Use a string index range instead. Okay. Can I do that? I don't think this is adding anything at this point. Cannot convert argument. How do I stride through string indexes? Ooh, is there an init that takes the suffix? Substrings. I mean, I could remove. Oh, there's this. Remove first. Let's try that. I thought this would be. Here I am, 20 minutes later. Uh, drop first. Returns a subsequence. Okay. Now the types don't match because, yeah, remaining code is string, but can I make this be a substring with this operator? Okay, my goodness. Alrighty, so we start with no lines and we start with the whole remaining code. While there's still remaining codes to put out, we write a new, find the new piece that's the first with the characters, put that out there, update the lines, update the remaining code, come back around and repeat. Okay. And the difference is drop first is okay with dropping 10 when it's only got 5 in it. All right, and let's do one more thing. Let's change this a little bit and make it sure it's not divisible exactly by 5. I believe it should be okay, but okay. So now the details carries through the maximum, makes use of the maximum width. Okay. And I think we only have one in our no scaling, but let's go check it out. One, 2, 3, 4, 5, 6, 7, 8, 16, 24, more than 32. Okay. So kind of in the middle even. Okay, so we copied that. Let's run. Well, surely this one. Yes. Okay. Nice. I mean, my goodness, but yeah, nice. I think we could probably go twice as wide though. All right, so let's every 64 characters. And let's make a default value here. Let default max code width equals 64. And hopefully I can put that there and there. Apparently not. Yeah, that's definitely tolerable. Yep. Yep. This is exactly 64. That one's a little over. Yeah, that's a good length. Okay, it looks like we got about 90 characters or so, 80 characters maybe. Alrighty. I would say that is done. Okay. I mean, this string thing still bugs me a bit. I think what would be nice... Well, I don't know. Would it be easier if there were something that said like string dot split with an int and split every, return an array of strings? Would that be an improvement? I mean, I think I'd kind of have to write the similar loop here. It'd be a slightly easier loop. Yeah, let's see if we can do that. We'll put it here. Okay, so this is function split every. It's going to take a string and an int. Max piece size. Okay, and it's going to kind of do this. Oh. We don't need the put. We don't need the lines. Reading equals string. Well, count as in 0. Get the next piece. That. Now we get to find out if this is any better. Okay, so we pulled out those pieces. This thing returns array of string. Okay. And we would call could call split every on code by max code width. Okay, that gives us an array. We then do a for each. And what are we going to do? Well, we're going to do a result.put. I guess we're going to have to keep track of lines still. Let's take the result.put. Plus equals 1. Let's take that out, see if this works. Okay, I'm willing to do that. I think that's a candidate for string more than this, but okay. Split every code, max code width for each one, put the piece. Yeah, okay. And let's commit that. So we've got refactor to split string to array of strings. Alrighty. Now this thing. This one's kind of just too weird. Okay, so let's find this. All right. So there is an invisible BOM space right there. If I hit delete, notice the quote doesn't go away. Okay, I'll hit backspace. I went there. Backspace didn't do anything. Okay. Let's take off the ignore. Okay, and run this test. Should blow up twice. Okay. And this one I'm going to try /u feff. Unexpected half. Let's see. How do we put a Unicode escape? Oop, that looked like it might be doing something. Oh, brackets. Okay. Where's check tune parsing? Okay, there we go. The notes didn't get detected because the junk that represents just gets, it should just get ignored. But what it's doing is it's preventing us matching the whole line. So we match all the notes, and then we got this weird character we can't see, and that doesn't get matched. And I don't know. I think maybe the BOM character is maybe that's the only one we have to really do. Tune parsing ignores BOM. Okay. Maybe it's the other way around. Okay. My solution for this. All right, let's go to our parser. We do some work on a line before we get going. Let's find that. Why is that messed up? I didn't bump anything. Value of type. Okay, let's just clean. Oh, cannot assign value of type character bind to pitch to character bind note. What? Build succeed. Okay, this is just weird. Build succeeded, except that it doesn't get rid of that error. Go back. Okay. I don't know. All right. Somewhere in here, where's the actual kind of main entry point is parse, find tunes. Yeah. Okay. We split. No, we split those lines. Where's the entity to string used? Okay, there we go. We do a replace HTML entities somewhere. Let's find the color of that. Line equals that. Okay. So when we start finding tunes, we start by replacing these entities in each line. Let's this thing should take a line. Okay, a substring and return a substring. Okay. Let's do this. We should get the same error. Those two bomb tests should fail. They should bomb. Huh. Okay. And they do. All right. So now let's get rid of it. Well, we know there's a replace occurrence of slash UFEFF with nothing. Both failed. Okay, what was this? Unexpected characters found. What are we calling? Find tunes. Input.split. Oh. Find tunes of lines. Did I call my new thing? No. What did I call it? Eliminate. Always helps to call it. Eliminate BOM characters before processing input. And that's sort of, I don't know. Normally you would only expect to see that at the beginning of a file. Let's see, BOM. Maybe BOM Unicode. So FEFF, if you have something that reverses byte order, you can detect that. That's one thing. It's supposed to be a 0 with non-breaking space. Okay. It's a magic number at the start of a stream that can tell people how the stream was encoded and stuff like that. It interferes with UTF-8. Yes, that's us. Normally it would be at the beginning, the first character, and if you see FEFF, it's not a normal character. Well, it's not a normal UTF-8 character. It's not a normal anything character. It's a special Unicode character. And if you see this, this particular Unicode character there, you've got Unicode. However, it doesn't really explain what to do when it's outside of there. Okay, in the middle of a stream, interpreted as 0 with non-breaking space, but then it's deprecated that you should use word joiner instead. Use this only as a BOM. Allows it to be. It's kind of like my complaints about all the formats that are allowed and so on. It's like statements like this should be this, meaning it could be that, but if it's not, the program has to deal with it. Okay, but at any rate, BOM is such a special character. I don't mind just getting it out of there. That's the way it is. Okay. All right. So let's make sure everything's running. So let's say what we really did. Make input stream ignore any BOM / UFEFF characters. Okay. That is good. No scale and report. I guess that's sort of the header for all of these. And that was this stuff too. Well, that was refactoring. This stuff was report. And this was report. We've been doing a lot of report. Note parser, yep. Okay, good. All right, so let's save that and check that in. Okay, well, let's see. A reminder, I'm off tomorrow. I normally do Monday through Thursday. I'm off tomorrow. I'm off next week, out a day or two on the week after that. So I want to tackle something that's relatively easy to do in the next half hour and leave things nice and clean. So when I come back, I'm not staring at tests going like, what was I thinking? Okay. Parser's getting too large. Well, what's too large? Hundreds of lines. In a way, what's going on? Some of this maybe could pull out. I think ABC parse error could pull out. That's a nice parse thing. What does that mean? It doesn't build, but it runs. There it goes. Okay. All tests. All right. Extract file ABC parse error. All right. Part of what's going on. All right. There's multiple things going on in here. That's part of the issue. So one thing is just this like pre-processing on the line that we're doing. That's kind of weird. Then there's the note line. That's almost complicated enough to be its own thing. I mean, it's a pretty big method. And then notes. Yeah, I mean that's a thing. And then each one of these, this is the X parser for reference numbers. This is the T parser for titles. I don't know why that's there. I think let's pull this up top. I mean, we're using it locally, so it's okay that it's in here. But it seems like there are several distinct pieces going on. Here's that HTML translation. That's almost its own thing. And then this stuff is managing the file content. So the outermost layer, you look for content, you find an X, then you get one or more T's, gather them, then you're either in the header or the body. You find a key that tells you it's time to switch to the body. All right, and this fine tunes knows that. Okay. So I do think there are pieces that we could break out that would be interesting. The next one is this notion of musical signs. I think maybe elements is maybe the better name. But let's go to the ABC notation. All right, yes, here's samples. Okay. Um, it, let's see. So the one thing that's significant here is these bar lines. Okay. Another is this, that's a repeat mark. And usually there's an open repeat, but if you don't have one, it's okay. We'll just assume it's there. What else we got different? Well, there's a meter change in the middle of the tune. So there's sort of an implicit meter. Here's a different kind of bar line. Guitar chords. And I don't know, it looked like syntactically they're attached to the note. I don't think they really make sense there. Because really, well, most of these are just written as single tunes melodies and not the harmonies or the other voices. So it's kind of implicit to them. But if they say play a C chord, you're playing against the one melody note. But really, if you got multi-voice harmony or multi-voice music, then the C chord applies across all the notes at that same moment. And ABC does have a way to notate that, so the fact that they don't distinguish that is a little weird to me. Okay, here's these trill notes. Like, are they part of the note? In a way they are, because their timing is totally taken from the timing of the note itself. And there's just a little quick kind of thing, oh, we're not going to write in 128th notes for some reason, whatever. All right, we've got brackets, and they mean something, but I forget what they mean. They can mean chords. They can mean inline changes and stuff too. Okay, so here's the key E flat. Yeah, so this is marking voice verse 1. I can't remember what V is. I think it's verse 1. Son questi crespi criniae, questi son glioci, kami. Glioci, I don't know. Not so good at that stuff. All right. Here's an interesting little blip. It's a fermata, and that's a little sign that looks kind of like an eyebrow over an eyeball. A little rounded thing with a dot under it. That just is in the middle of the line. Here's this colon. That's a little weird. I don't know what that's indicating there. I mean, I think of colon as part of the bar line. It can be a bar line thing, but that looks like maybe that's not. Okay, so let's go find out what V colon is. But you can have arbitrary stuff in there. Yeah, so this table says, oh, voice. Oh, so that's multi-voiced stuff. V4 clef bass. Right, so we have these ones that can be in the tune body. You can switch meters, switch note length, switch a bunch of stuff in the middle of a tune. All right, those go in brackets as well. I think you're supposed to, the distinguishing thing is like bracket V colon is different than bracket G4. It's different than maybe some other use of bracket. Okay, so voice 1 is FDEC, voice 2 is ABGA, and voice 3 is rest DBCD. Oh, lower DBCD. Okay. Singing similar words, but not identical. Yeah. So at any rate, I've got a voice marker. I've got a bar line. I could have parts. I don't know if there are any here. Well, this is, okay, Kitchen Girl. It's got, normally we would say AABB. It plays this part, hits a repeat, plays it again, switches keys to G, plays this, and then plays this last part again. Okay, so that's interesting. But at any rate, the bar lines, the voice markers, the key changes, all that stuff is sort of in the stream of the notation. And some of them are local. Let's see, like the trills, grace notes, and some of them kind of have an ongoing impact. Like everything from here on is G until somebody tells you otherwise. And then some of them are, I don't know, the bar lines, they're mostly local, but they have some more global context they fit in. The fact that these bar lines are there up to the repeat is interesting. There's also this notion of pickup notes, which is notes that come before the first bar line. I'm not sure if that's what's going on here or not. It seems weird to have one in each thing. It would be what they call crooked. Maybe it is. Okay, let's see if we can find out what these brackets are. But at any point, in any case, I think there's a stream of events going on, and we don't have enough to tell us there. Okay, you could put, that's bracket R colon. Information fields may be enclosed in line with this. Yeah, that's what we're doing there. Fields within the tune body. Okay, there's an example. A meter shift. I think bracket here is more saying optional. You can say just the clef name, or you can say clef name, clef equals. Let's get past those. It can mean a bar line. There can be an invisible bar line. Putting the bar line in brackets. Okay. That's more of a bar line thing. Bracket ending 1. Repeat 1. Variant. Okay. So bracket by itself with a number, it's okay. Like, I don't know, they've they've got so many variants of these things. Okay, what's this? Decorations may be applied to notes, rests, or groups. Bang 1. Oh, bang 1, 3, 5 is playing that chord and then putting a coda symbol, a Y, I don't know what that is. A P, don't know what that is. Oh, piano, soft. A trill, TR, and a C under a fermata. Well, there's that eyeball thing I was talking about. Why they're in brackets there, I don't think they've said. P, no, those don't tell us. Okay. But in any case, these really are indicating something at that position, but they're not the note per se, I wouldn't say. Let's find more brackets. Symbol names may not contain brackets. Good. Chords and unisons. Okay. Oh, okay. So if you bracket around notes, then that says draw them all as a chord. Okay. All right. So I'm good with that. Put in under the melody line using double quotation marks to the left of the note as it sounded. Okay. So they're kind of saying chords can be put in at, it's kind of attached to that note A, but normally you you strike a chord, it sounds for some amount of time, and I don't think that's really telling you what that is. Grace note, chords, annotations, decorations, accidentals, notes, octaves, links. Okay, so one note has a bunch of stuff going on, but notes aren't the only thing. All right, let's see what we can do. All right, so what I think is going to happen is the result of parsing a line is going to not be a series of notes, but it's going to be a series of elements is the word I'm using. I don't know if we can find a better domain term. I've certainly heard musical symbols, musical elements. It'd be nice to know what these guys call it. Music code, I don't know. Notes, bars, and other symbols. Yeah. Okay. Use of fields within the tune body. Okay. Right. So what I think is going on is that the concept somewhere we have notes under domain. Okay. Notes is a sequence right now of note. Oh, and the word element is element. Do I really want to get down that track? The change I want to make is to say, I want to make a special case out of note. Where is note? Okay, there it is. So somewhere I kind of wanted to find an enum. That's probably doable in 15 minutes, but I want to say enum I got to find the right word for this element, and that's one possibility, and that's the only possibility right now. If I could shift this to that would be a step forward, but it's going to change a bunch of people that are looking for plain old notes. Okay. Now I don't have to forbid it. I just have to make sure it's all wrapped, right? Let's see if we can do that in here and hide that from everybody. Okay. And the sequence is note. Okay. All right. So I want to make this be musical element. Okay. Now, people should be complaining. Yes. Let's map this to dot note with $0. Okay, so you give me a bunch of notes and I will give you I will wrap them all in the musical elements. Okay, now I want the iterator for notes. It's going to give me back notes. Okay, so I'm going to do another map. All right, and then this, well, I'm going to switch $0 of switch $0 case note of let note. I can do that. Okay, so what's that? Okay, so when you make an ask for an iterator, I'm going to map every element back to the note and iterate over that. And there's only one other place, LHS.notes. Musical element must conform to equatable. Okay, let's do that. Extension musical element is equatable. It should be volunteering. Like, can I write the function header for you? Oh, maybe it doesn't need it because node is equatable. Okay. I guess that's cool. Okay, let's find note. Somewhere down here. Node is equatable. Okay, so my notes are equatable because notes, if they have the same set of notes, they're okay. All right, and their notes are musical elements. All right, let's make sure everybody's happy. There may be a test that's snooping a little more than some of the others. Okay. That's great. Okay, so add musical element used in notes. Now, I don't know if notes should be the sequence. See, the thing is, the clients of this, many of them are expecting just notes, and we've mapped it so that they get that, but this really should probably be returning the musical elements. Okay, so I don't know how far down to go. Like, how many people are calling? Well, how many people reference this type? That would be an indication. Yeah, quite a few. Now you can pass in notes, so that's no problem. Okay, here's parser. The parser produces notes. You can build that parser. And then what's this one? Given a bunch of notes, we can produce them. Yeah, okay. Notes, input string yields notes. I kind of don't think notes is the real name either. Okay, that's all that stuff. Parsons code needs notes. It maps them to pitches. All right, let's make a change. If I say this is musical element, excuse me, and then I probably need to take this off. Okay, and array of note. This is array of musical element. I want to see things break. Like who all cares? Type element and music note be equivalent. Where is that? Sequence requires the types notes.element, musical element, yes. Notes does not conform. Array. Well, sure, let's add the stub and see who's missing. Make it an array of note. Oh, that should be musical element. Okay, this one builds. Let's see who else breaks. There's going to be a bunch that break. Well, that's not a bunch, is it? I mean, it's something. Type of expression, because they're not able to map there. Okay. Notes.map to 0.pitch. All right. Who's gonna convert notes to pitches? It seems like either this or the caller. All right. I mean, if you iterate over the musical elements, you get them. I mean, maybe this thing should be the filter. Okay, so notes dot filter. Well, I can switch. I can give this a helper method. Today, that's true. I don't know if I can say filter of, no. $0.is note. Okay. Well, I don't. Okay, I'm going to take a shortcut. I don't know. You end up writing these helpers sometimes. Okay, to force it in. Okay, dot note. Okay, and we'll just say filter this. There's another kind of map. Okay, that should build. And let's run it. We lost our no scaling. think it's there. Yeah. Okay. So, I mean, I think we're taking the first steps here, but um, this now doesn't need this anymore. Creating it this way, yeah, add more notes. Okay. Right now it's all very focused on notes, but I think it's not going to be. I mean, I think there's something we can do there. I don't know. The the thing I have in mind, and I'm not going to do this in 4 minutes, but um, there's really this kind of hierarchical structure to music, and then there are other structures that wrap over top of and independent of the hierarchy. So measures, well, you have measures and they're in repeat sections. Let's see, down in the examples. Okay, I don't know if we can find a. Okay, yeah, here's an example. This has PA, PB. Up here, the P in the header section says AB2, AC2A. That means AB, AB, AC, AC, A. So here's the A, here's the B, and where the heck is the C? Right here. Okay. And so this tells you this sort of overall part structure of things. Within that, I don't know. We'll have to figure out the interpretation here, but this says repeat. This says repeat. I don't know if it's going to repeat AABB, AABB, or quite what the interpretation of this part stuff is. Okay. It could mean A's are repeated twice, B's are repeated twice, then A twice, C twice. But that's the basics of it anyway. So I think it's probably A B A B A C A C A. Okay. But anyway, there's this part structure. It overlays on top of this repeat structure or segment structure. Then there's the bar lines within it, and within that are the notes. Now, there are the notion of ties where you may hold a note across bar lines, or you may be, well, that's probably the one to talk about. It says this note carries over across the bar line. Well, that's independent of the bar hierarchy. It's, that note has its own duration that doesn't care about the bars. So I think we eventually need something to represent kind of parts, and then these sort of sections, and then repeats within sections, and like the part might contain multiple repeats or something. And there's this notion of variant endings. So you might play it one way the first time and then a second time with a variant ending. Okay. Like the big finish. Okay. That's a variant ending. Within that bar lines and within that notes. And then you have these, slur is the other one I'm thinking of. I can have a sequence of notes, A, B, C, and they have a slur over top of them that sort of says these form a phrase. And again, the phrase can be independent of the bar lines. You can actually have multiple phrases, nested phrases, probably overlapping phrases. I don't know. I don't see that, but it could happen, I guess. Probably not in this format. I think the way it works is the nesting of parentheses, but it's possible that they cut across the bar lines. Okay, here's a phrase, G, F, E, D, E. Okay, da, 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 whatever. And carrying across. So I feel like we have this stream. We should construct these bigger structures around it, nest them where they can, and then we somehow need to talk about where the places are on the other ones if we get to caring about that. So I don't, it's a lot of potential complexity. All right. Anyway, thanks for joining me today. I'm glad we finished the reports. And like I said, I'll be away a week and a half. And when we pick up there, we're going to we'll do a little more of these musical element stuff. I do want to bring out this concept a bit more than we have it. The bar lines and stuff will matter in our next. Well, I'm not quite sure what we're doing next on the reporting front, but if we want to do these quantized ones, we have to keep track of the measures and the quarter notes and whole notes and durations and stuff. So eventually we'll need to do some of that. All right, take care, and hope you have a good weekend. Bye-bye.